Hi everyone. In this video, we're going to focus on a few facts about the GCF and LCM. Notice that these are just a few of the facts about the GCF and LCM. There are many, many facts that we could delve into. In fact, the mathematics majors at our university take a course called Number Theory, and much of that course focuses on the GCF and LCM. We're just going to focus on a few of them. The first fact that I'd like to delve into, fact 1 I'll call it, and it's a formula that I'll call the reduction formula. So it's if you want to find the GCF of two numbers, A and B, and A is greater than B, so one's greater than the other one, you can do that by using this fact that the GCF of A and B is equal to the GCF of A minus B, that's the larger minus the smaller, and the GCF of B. Those two greatest common factors are the same. So let's illustrate this formula, which we'll call the reduction formula, with something that we already know, the GCF of 16 and 20. You should be able to see that the greatest number that goes in to 16 and to 20 is equal to 4. 4 divides 20 and 4 divides 16. It's the largest number that divides each of those. So it's the GCF. Well, let's use the reduction formula and see if we get the same result. So the GCF of 20 and 16 is equal to the GCF of 20 minus 16, larger minus smaller, and GCF of 16, which is the smaller. So that's the GCF of 4, 20 minus 16, and 16. So what I've done is I've reduced the GCF of 20 and 16 to the GCF of 4 and 16. They're equal. I haven't done any GCFs. I've just said these two GCFs are equal. I could probably stop right there. I know that's 4. That's the largest number that will go into 4 and 16, but let's keep going and see if we get something that's even nicer. GCF of 4 and 16 is equal to the GCF of 4, which is the smaller, and 16 minus 4, larger minus smaller. So that's the GCF of 4 and 12. Let's keep going another step. The GCF of 4 and 12 equals the GCF of 4, the smaller, and 12 minus 4, larger minus smaller. So that's the GCF of 4 and 8. Let's go one more step. The GCF of 4, the smaller, and 8 minus 4, larger minus smaller, equals a GCF of 4 and 4. So what this reduction formula does is it allows us to conclude that the GCF of 20 and 16 is equal to the GCF of 4 and 4. And I can just say, okay, what's the greatest number that goes into 4 and 4? That equals 4. So the GCF of 20 and 16 equals 4. Well, let's use this formula with some numbers that makes a little more sense. When you have larger numbers, sometimes it's easier to actually reduce it rather than finding the prime factorizations and so forth. So the GCF of 1050 and 1625. I could use the prime factorization, but let's use a reduction formula for this. The GCF of 1050 and 1625 equals the GCF of 1050, which is the smaller, and 1625 minus 1050, larger minus smaller. So that is the GCF of 1050 and 575. That's patently obvious, so let's go another step. The GCF of 1050 and 575 is the GCF of 525, which is the smaller, and 1050 minus 575, which is the smaller, larger minus smaller. So that's the GCF of 475 and 575. Going one more step, GCF of 475 and 575 is the GCF of 475, the smaller, and 575 minus 475, larger minus smaller. So that's the GCF of 475 and 100. Now we're getting somewhere. If I keep going through this process and keep reducing, I'm going to get down to the fact that the GCF of our original 1050 and 1625 is equal to the GCF of 75 and 25. These two are equal. Again, I haven't taken the GCF, but I've gotten to the point where I can look at that and say, well, what is the largest number that divides evenly into 75 and 25? That's equal to 25. So the GCF of 1050 and 1625, by reducing that, is equal to 25. The second fact that I'd like to delve into is a fact about the GCF and the LCM and how they're related. Fact 2 states that the GCF of two numbers, a and b, times the LCM of a and b equals the product of those numbers, a times b. Let's check that out with something that we've done. In earlier videos, we've found the GCF of 24 and 30. We found the LCM. So let's just check. Does the GCF of 24 and 30 times the LCM of 24 and 30, does that equal 24 times 30? Well, 24 times 30 is 720. The GCF from an earlier video of 24 and 30 is 6. The LCM of 24 and 30, again from an earlier video, is 120. So the question is, does 6 times 120, the GCF times the LCM, does that equal the product of the two numbers? Well, 6 times 120 is 720. 720 does equal 720. So that fact checks out. Now, let's use this fact for a few simple problems. Sample problem number 1 states that if the GCF of 240 and 600, if that equals 120. Let's use fact 2 to find the LCM. In other words, rather than you finding the LCM using prime factorization or some other method, I'm going to use fact 2. From fact 2, we know that the GCF of 240 and 600 times the LCM of 240 and 600 equals the product of those numbers, which is 240 times 600. That's what fact 2 states. Well, I know that the GCF of 240 and 600 is 120, which we've actually completed in an earlier video, times the LCM of 240 and 600, which is what we're trying to find, equals a product, which is 1440. If I'm trying to find this, I know that 120 times what I'm looking for equals 144,000. So if I divide, if I'm solving that equation for the LCM, I get that the LCM equals 144,000 divided by 120 equals 1200. So without actually finding the LCM, but just using this fact, I know the LCM of 240 and 600 is 1200. Sample problem number 2 on fact 2 says that if the GCF of two numbers is 21 and the product of those numbers is 154,350, use fact 2 to find the LCM of the two numbers. Again, from fact 2, this is where I would start. I just state fact 2. The GCF of A and B times the LCM of A and B equals the product of A and B. Well, what do you have? You have that the GCF is 21. We're trying to find the LCM of A and B, and that equals the product, which we're given is 154,350. Solving for what we want, the LCM of 240 and 600 equals 154,350 divided by 21, which equals 7350. So without actually finding the numbers, if I know that the GCF of the two numbers is 21 and the product is 154,350, I can actually find the LCM as well. Finally, sample problem 3 if the GCF of two numbers is 24 and the LCM of the two numbers is 28,224 and one of the numbers is 576, what's the other number? Again, I'd start off with stating fact 2, the GCF of the two numbers times the LCM of the two numbers equals the product of the two numbers. So the GCF of the two numbers is 24. The LCM is 28,224. And that equals A, which is 576 times B. Oh, B we don't know, so we'll just write that as 576B. That yields an equation, 677,376. That's hard to say when you're recording a video. Equals 576B. When I solve this equation for B, I have that B equals 677,376 divided by 576, which equals 1176. So the two numbers in this problem that I was working with were 576 and 1176. And I'll leave it for you to check that the GCF of those numbers is 24 and the LCM of those numbers is 28,224.